we're going to look at an extra feature, which is the flood module. This is not a required part of the model, but it's something you may consider including in your modeling. So the flood module accounts for a reduction in flood damage costs. So for example, if you have something like green infrastructure, stormwater BMPs you're considering installing, that's a certain cost and it will have certain benefits on the water supply. But it may also have flood damage reduction benefits. For example, it's going to reduce your peak flows and the frequency of your peak flows. So it will flood your properties and assets less, and accounting for that avoided damages may make the stormwater BMPs more cost effective than without accounting for the flood damage costs. So what does the flood module require? It requires at least 3 sets of data points. And the sets of data are average daily stream flow, return period, how often does that size flood flow happen, and what is the associated damage with that flood flow. So for example, if you have 50 CFS and it comes every 5 years and it causes $1 million in damages, that would be one set of data points. And we require at least 3 sets of data points. And in one moment, Elisa will cover how to derive these input data. Based on these 3 data points, the model calculates the annualized loss, which is simply the flood damage cost divided by the return period. So how often does that damage occur? And then when the model runs, it compares the calculated stream flow to the flood flows that you provide. And if the daily stream flow is less than the smallest flood flow you provide, there'll be 0 avoided damages. If there is somewhere between the smallest and largest flood flow you provide, then the amount of damage related to that flow is linearly interpolated between the 2 values. Finally, if the daily flow is larger than the largest flood flow that you provide, it'll max out at that maximum largest flood damage you provide. So it's not going to extrapolate. It only interpolates. So based on those damages, those are added to the cost. So now it calculates into minimizing those costs. So when you implement a stormwater BMP, for example, and you manage to avoid a flood flow, you will reduce your total cost of management. Is there any accounting for increased rates of flooding with climate change? Is that built in, or do we add a value to that? That's a good question. So the question was, is there a way to account for climate change potentially causing more frequent flooding? The way you would account for that, and I will go over it under optimization scenarios, is to run the model for a different set of runoff recharge values that represent a projected climate scenario. And as Naomi will talk about towards the end of the day, there are data sets that we're working on processing so that they're provided to you similarly as the baseline hydrology module. So those would be separate data sets. Great. So this flood module is relatively straightforward in terms of how it works, but there are limitations that we need to keep in mind for how to interpret it. One is that it requires daily flow, not peak flow. So a lot of flood flows will be instantaneous peak flow, whereas here we're asking for daily flow, which matches what the model does. The model will calculate daily flow. So if you use the flood module, you must run the module in a daily time step mode and make sure that the flood flows are daily, not peak. Now, to try to get at those values, you can look at USGS Peak FQ, which is a software to calculate peak flows, and state-level regression equations provide peak flows. And then you can compare those to the USGS stream flow gauges that provide average daily flows to try to walk between the two, between the daily and the peak flows. The other consideration is that you need to have a flood flow in your modeling time period. So if you're doing a 5-year period that happens to be a dry period, you might not get a flood flow, and in that case, the flood module is not going to make a difference. You're going to get the same exact results with or without the flood module. So you can check your stream flow without the flood module if you already ran it. For example, the first step when you set up the model is you're going to run it and compare it to stream flow data that's measured. That's your calibration validation, which we'll also cover. So you can compare it to the stream flow and see if, in fact, there is flooding occurring. And you can also even look at it a step earlier. You can look at the precipitation record and find a wet year and run that year. Finally, the third consideration is that if there's multiple consecutive flood flows, the model may overestimate the avoided cost benefits. So that if I have a flow that goes on for 2 days, the model will assess the damage on both days. So in a sense, it'll double count those costs, and then if your BMPs reduce the flows below the flood flow, it's going to take away both of those costs. And you can again check for this by looking at your flood flows. Did I have a flood that occurred for 2 whole days or 3 days, or did I have consecutive flooding, for example, within a week? Within a week, I wouldn't repair all my damaged assets. So now I'm going to turn it over to Lisa to tell you a little bit about how to get at those 3 sets of values that the model requires to.
Okay.
So while we're getting hooked up, are there any questions on that part of the flood module? Yes.
I'm just curious to know, does it take into account kind of climate change projections? What used to be a 1 in a 100-year flood is now, for example, becoming a 1 in a 10-year flood?
Right, so the question is, does this, the flood module take into account that the 1 in 20-year flood will be different in the future? Yep, so what you would do is you would take the runoff and recharge values that we specify, those time series. That's for based on historic, so we're taking a historic period. So we would want to modify that to reflect a projected future climate scenario and rerun the model, and that's how you'd account for it. So there's not an automated way. And we're going to have, we're in the process of processing data so that the baseline hydrology data sets, you would have not only historic, but you'd also have projected future climate change data sets.
Very cool. Like for region or?
So they will be for the, they are for specific watershed models that we have. One is for New England. It's a really large SWAT model that does coastal New England. And then one is the Chesapeake Bay, one of Susquehanna watershed, one of the big watersheds in the Chesapeake Bay. And then there are other plans that Naomi will speak about in the afternoon. And this is similar to the other ones where you can always supply your own data, or if you know that, if you know how the hydrology is supposed to change, you can modify the runoff recharge time series. You know, it would be pretty crude to say, oh, multiply the runoff time series by 20% because there's going to be 20% more precipitation. So I wouldn't advise that, but that if you have something more specific to go on. See a black screen. Any other questions? Oh, I did have one question during the break that I will answer to the group, and that was, how do you change the cost of the stormwater practices that are put in by default? So in the land use tab, the stormwater module will populate the default costs we compiled from literature, and it will put in the capital cost, so what it costs to construct the BMP, as well as annual upkeep costs to keep the BMP functioning. But you can change those. So we input the areas of HRUs within our study area in the baseline land use table, and then underneath that there is a table for each stormwater BMP that you might consider. And you specify how much area is available for each type of BMP that you're considering. And after you specify the minimum maximum areas available for stormwater BMP, the next 2 columns are capital costs and O&M costs.